So today we're going to be talking about transformations of trig functions. Now we've already talked about transformations of basic functions. We talked about that in class today. This should have been reviewed. Transformations were done hopefully in Algebra 2 and integrated math. So hopefully that was all reviewed, and we're going over it now with trig functions. Okay, trig functions, there are no differences as far as the transformation is concerned. They do the exact same things. Graphing on graphing calculators is fine, but I want you to have like a general sense of what's going on. So you will have to answer some questions as far as, you know, what is what does the transformation do? So this right here is an example of graphing the cosine function and 4 times the cosine function. Okay, so you'll notice the cosine function looks like this. All right, that's the basic cosine function. Our transformation, multiplying it by 4, is going to stretch the graph by 4 units. So we have a vertical stretch, which means it pretty much stays in the same place. It's just being stretched by 4 units. All right, and that's it as far as this type of a shift. Keep in mind that, again, all of these things that I'm asking you to do, you should have already done with the basic graphs. So the parent function is cosine t, we multiply by 4. It vertically stretches by 4 units. Okay, next example. Okay, so we're going to graph the 1/2 sine of t, negative 1/2 sine of t on the interval, negative 2 pi to 2 pi. All right, so now this, you might have to draw some pictures. That's okay, all right? If you want to use your graphing calculator to help you draw those pictures, that's fine too. Again, but I want you to have a general sense of what's going on. Okay, when we multiply by a negative number, we reflect over the x-axis. So you'll notice here, the light blue line, the dotted line, is the actual function. That's the parent function. Okay, so you notice we reflected over the x-axis. Then, we have a vertical stretch of 1/2. It's always interesting to think about this as a vertical stretch, but 1/2 is less than 1, so it's actually going to squash the graph just a little bit by 1/2, actually. So you'll notice that it is now, the graph is squashed. It's going through 1/2 instead of 1, okay? So we've shrunk it by 1/2, and we have inverted it over the x-axis. So you should be able to graph these, just basic pictures. They don't have to be perfect, but that you can show what the transformation is doing to the parent function. Okay, tangents. Tangents are a little trickier because there's all those asymptotes, okay? So this is a simple transformation of tangent, and it will usually tell you if you need to draw a picture over what interval, because obviously the sine and cosine functions go on forever and they're repeating. So this one says I want to go from negative 3 pi to 3 pi. So you'll notice here, all I'm doing is adding 5. When I add 5, I physically pick the graph up and lift it 5 units up. So everything will be going, will just be 5 units taller than it was before. It's not a stretch. It's not stretching it 5 units. It's just physically moving it 5 units up. So where everything was going through the 0 before, it is now going through 5, or in that sense, right? So the graphs have all been shifted up. You can't see it. The graph hasn't changed. It hasn't stretched. It hasn't gotten skinnier or wider, but it's just physically moved up 5 units. Asymptotes stay in the exact same place. Everything stays in the same place except for the fact that we moved it up. And that's it. You should be able to draw these pictures, keep the asymptotes in the same spot. But now the y-intercept is 5 instead of 0. All right, so this one says list the transformations that change the graph of f into the graph of g and state the domain and range. Now we haven't talked a whole lot about domain and range, but I think it's important that we do discuss this, okay? Domain and range of sine and cosine functions are absurdly simple. Tangent's a little more complicated, all right? So sine functions, the domain is all real numbers. Okay, so for a basic sine function, it's all real numbers. Okay, and this is actually the same thing for sine and cosine. Okay, when we graph a sine function, it oscillates between 1 and negative 1. So the domain, or the range, for sine and cosine functions is, and cosine, they're the same. It's from negative 1 to 1. Okay, and you could, I drew that wrong. So negative 1 to 1. So that's my domain and range. You can write this. I'm not asking for it to be in any specific notation, but that's my domain and range. So domain is all real numbers, range is negative 1 to 1. This range is what we're going to be mostly concerned about when we are doing shifts, okay? Because we do a vertical stretch, or if we move the y-intercept, obviously the range is going to change. So, so let's look at that on both 34 and 35. These are questions out of the book. I'm assigning other problems for the homework, but anyway, so let's look at this. So if we have cosine of t, and we want g of t equals the cosine of t minus 2. So the first thing we need to do is talk about the transformation. So the transformation is a physical move down 2 units. All right, so it's just physically moving down, it's changing the y-intercept. All right, now, because we've done that, that has now changed our y-intercept. And if it helps to graph it on a graphing calculator so you can see it, that's fine. So now we're down here, which, for the cosine function, now we're down here, so it's going to be oscillating down here. I know this isn't perfect, it doesn't cross there, but down here instead of across the 0 axis. So the domain's going to stay the same, it circles on forever, but the range is going to be from this point to this point. So we know that this has a range of 2, or not I want to say range, but like that from the bottom point to the top point is 2 units, because we went from negative 1 to 1 before. So what are we at now? Well, with the cosine function, the domain and range is going to be, I meant to talk about these on the other ones, I apologize. Okay, the domain and range is going to go from negative 3 to negative 1, because instead of being up here at 0, we're now down here. So it goes from negative 3 to negative 1. Their domain is still all real numbers. And honestly, that's not going to change. All right, now the next one, the cosine, flipping the graph. Is, okay, we're just going to invert it across the x-axis. So we're just going to reflect over x-axis, so that's the transformation. And my domain and range, okay, obviously it's actually not going to change because I've simply reflected. I'm still going from negative 1 to 1. So my domain is still all real. And my range is still from negative 1 to 1. I'm going to keep doing it. Alright, moving on. Alright, some of these are going to ask you to sketch a graph. Okay, you don't have to be perfect. Alright, so if I'm going to sketch the graph of this, I need to know what's happening first of all. So I'm going to actually do a basic graph, and I'm going to just draw the cosine graph really quick so that I have a picture to base my assumptions off of. All right, so the cosine function crosses the y-axis at 1, okay, and then it's going to go down here, okay, like this. Again, I don't expect your pictures to be perfect, just make sure that you're crossing the axis in the right spot. So cosine crosses at 1, sine crosses at 0, there are opposites there. This is 1 and negative 1. So this is my basic function, this is the cosine. Now, if I want to talk about what's going to happen to my, with this, it's first of all, it's going to reflect. So my loops are going to be in the opposite spots. Okay. The second thing it's going to have to do is going to be a vertical stretch. So I'm actually going to stretch my graph. I'm going to go this way by 2. I need to go up a little bit further. Okay. Again, the picture's not perfect. Okay, I don't have a graphic paper. I should have probably posted some on there, but I don't expect, pictures to be perfect. Graphing calculators will help check your work. Oh, that's really messed up. But you show the stretch, okay, that it goes higher and lower, it's stretching by 2, and it should be crossing in the same place. There's no shifts of the x or y intercepts. So, and that's it.